In today's video, I am going to check out an amplifier using the XY mode of an oscilloscope. Basically, what you're looking at now, that diagonal line, that's the simplest Lissajous figure there is. And that's what I'm going to use to show clipping, phase shift, or distortion, if possible. Now what I'm using here is a amplifier as a test subject, just an old Kenwood, and of course I need a scope. I need two probes, and on the back here I got to feed a signal into the input. I'm using the tuner or aux input, and I have a dummy load, and this is the 8 ohm dummy load. This is what the amp is rated for. And up here you can see I'm using a audio generator, and I'm just going to go ahead and feed in a standard test frequency of 1000 Hertz. What I'm going to do is bring the amplifier up to its rated maximum, and of course the rated maximum, you can find that out by just hooking up a AC voltmeter across the dummy load. Now this is a way of checking out amplifier, for example, for distortion. If you ever looked at a sine wave, unless it's like clipping or really messed up, it's kind of hard to see how much distortion it has. Now this is like a step up from that. I don't think it's the ultimate test. The ultimate test would probably be with a distortion analyzer, but it is a little bit better than just looking at a sine wave. It'll show me, for example, the clipping, phase shift, distortion. Well, the clipping, if it clips this diagonal line, it'll make some straight lines at the end. And if it's got distortion, you'll see the line curve. And if it's got phase shift, the line will open up and start getting round. Now, supposedly phase shift is not really hearable, and I've personally never been able to hear anything, but that might just be me. So what we do is we do one channel at a time, and we connect the output of the audio generator to the input of the amp. Again, I'm using the tuner, the aux input of the amp. That's what my audio generator is hooked up to. And the output of the amp is connected to a load resistor. It's 8 ohms or whatever the amp or receiver is rated for. And across the load resistor we connect the scope probe. That goes to the vertical input. And we connect the the plus lead of the audio generator to the H or X input. And of course we got to let the equipment warm up for a couple minutes. And that mess here is what I was talking about. This scope probe is going to the vertical input, and this is going to the horizontal input. This is basically across here's the leads from the audio generator I'm touching now, and here I've got a connection where my finger's touching back here. That's going into the aux or tuner input, and of course my scope probe is across that so I can get the signal. And my scope is in the XY mode, or sometimes it might be called external. And here again you can see one probe is now Y, and the other one is here X, or horizontal. So I kind of made a primitive little drawing. You can see what I was talking about, the audio generator to the input of the amp. Then there's the output of the amp. There's a load resistor across that, and here's from the vertical input of the amp going across the load resistor, the probes. And here again the scope is in the XY mode. Then the horizontal input is being connected through the probe across the audio generator and the input of the amplifier. It's kind of a hokey drawing, okay, but I only took a couple of minutes to draw that just to kind of make this a little bit clearer. So now, I now turn the amp up to its rated power output, and I have to know how much voltage that is, how much RMS voltage that is. So what I do is I take the formula P times R, which is the power, times the resistance. In this case, it's, I know from the specifications, 30 watts per channel, times 8. And that 30 times 8 gives me 240. And then I take the square root of that. I think that gives me somewhere around 15.49 or 15.5 volts of AC. So that gives me then the rated power output, because sometimes amps can put out more than the rated power output, but they might be having somewhat more distortion. Say if this amp is rated at 30 watts per channel and it's actually putting out 32, and I'd be measuring at the 32 watts per channel. Of course, that would give me wrong readings since it's only rated at 30 in actuality. So once I got that set up, I'm going to go ahead and do this here. Now using my audio generator and the AC voltmeter, and then I'll see what I get. So the equipment's warmed up and I've got the audio generator turned all the way down, and I am now going to turn up the volume control of the amplifier. Also, I have all the controls in a neutral position, such as loudness. This amp also has an equalizer. I've got that turned off, so everything is basically neutral. Then what I do is I, of course, bring up the volume control, and I'm going to bring that up all the way, and then I slowly start increasing the output of the audio generator. I slowly bring it up. So that's the rated power output right there. I've got my AC voltmeter now hooked up across the load resistor, and that's what I'm getting. That's 30 watts per channel. So that being said, I'm now going to go ahead and turn the volume all the way down from max and put the scope probe across the load resistor again and remove the AC voltmeter. Best to turn things down or shut things off. Of course, I know how much signal output now my audio generator needs to put out with the amplifier at maximum volume. So that setting there is going to give me the rated output. So now I connect things again. And now I go ahead and increase the volume. I think I should also explain why this test can be used. Normally, if you do a test with a sine wave or something, of course, each audio generator makes distortion too, and basically that's going to be added to the output of the amplifier. What this test does now, here, what you do is basically you disregard the distortion of the audio generator, because what you're doing basically is you're checking the signal when it goes into the amp, and you're comparing that with the signal when it comes out of the amp, and you disregard the basically the distortion of the audio generator. It's kind of like if you would take, for example, a kitchen scale and you want to weigh some flour in a bowl. First you put the bowl on the scale and you zero it out. In the end, that's not going to count toward the weight. You're kind of like, this is a very loose analogy, doing the same thing. You're just going to be measuring what's in the bowl. And this is the same way. Again, you check the difference between the input and the output of the amp, not what comes before. Hopefully that kind of makes sense. It's not really that easy to understand. Okay, anyways, this thing is putting out, right now, it's rated 30 watts per channel. And you can see here, I don't even know what frequency I'm on. I'm on 1,000 hertz. Basically, you could do this at any frequency I think the amplifier is rated for, but I think if you go the higher you go towards the frequency limits, then probably it's going to show more phase shift at the higher frequencies. Now, basically, I've only did this test at the 1,000 hertz. Basically, the 1,000 hertz with a 1,000 hertz sine wave, I mean to say, and not above that. So let me go ahead now and show how clipping would look out. Here you can see in fact you can see here a very small amount of phase shift. Now this line should actually be perfectly straight. So I had to turn off the room light so this could be better seen. I don't think I can, my camera I can't even focus. Anyways, it's got a slight opening of the lines, and I mean, I've never been able to tell with phase shift as far as my ears go. I can never really hear a difference. So again, I'm at the rated power output, and the line is basically totally straight, and this is at 1,000 hertz. So let me go ahead and overdrive this, or rather take it past its rated power output. Let me turn the light back on so I can see something. I can't work in the dark. And zoom out somewhat. So now we pay attention to the line and see what happens. Again, this is going to, I'm going to overload the amp now. I'm going to take it up to clipping. If we would be using a sine wave, we would either see a flattening of the peaks of the sine wave, either positive or negative or both. So let's go ahead and see what happens here. Taking it up now. I got to play around with the controls here. The amp's getting hot now. Right there. You can see that very clearly right there. I don't want to let it run that long at this. But right here, that flattening and that flattening, that is clipping. Let me turn this down. Don't want to do this forever because, well, don't want to blow something up there. I don't know if I should the light on. Try that again, just for a second. Maybe it can be seen better this way. With the light off. Here we go. That is clipping. So again, I'm at the rated power output, and let me go ahead and turn up the frequency from, I'm at 1,000 hertz, right? And see what happens when we go up to, let's say, 10,000. No, I'm going down, so see what happens if we get phase shift. There we go. Well, we're at 46,000 hertz, or 46 kilohertz. That is a little bit too much. I don't remember exactly what this thing was rated for. Well, let's say the audio spectrum is from 20 to 20,000 hertz. So right now I'm at 20,000 hertz, and again, I don't know what this amp is exactly rated for, but I think the more you go to its limits, the more phase shift is going to show here. Now, I don't know if this, in this particular amp, whether it's built in like this or if capacitors got to be changed or something like that. But there it is. It's 20,000 hertz. Again, I've only did this at 1,000 hertz. I've never bothered to do anything else with this, or I mean at different frequencies. And here's 100 hertz. That's 20 hertz right there. You see the trace is starting to slow down, and you can see you got a slight opening here, but it's probably, again, probably something I wouldn't be worried about. I don't think this thing has any notch distortion I can show, but I think I do have some kind of a setup here where I can show notch distortion. I'm not sure. So I'm back to my 1,000 hertz. Again, this test is a little bit more accurate than just looking at a sine wave, but I mean it's not as accurate as when you take a distortion meter. If it was like had a lot of distortion, and you would see this line here would be it would get some bows in it and be curved, but this really doesn't have it. So I would say overall this amp checks out okay.